So to further continue after the troubleshooting, we are going to see some safety protocols in fault tracing. Here we go. In the context of electric vehicle diagnostic system, fault tracing, that is the process of identifying the source of malfunction, must be carried out with strict adherence to safety protocols. This is due to inherent high voltage and high current systems involved, which can be lethal or cause significant damage if mishandled. This is extremely important because it can even cause fatalities in case of any mismanagement or mishandling. So, what are the safety protocols critical in EV fault tracing? EVs involve high voltage components typically between 300 and 800 volt DC, high energy batteries, electromagnetic fields, inverters and power electronics, and thermal management systems. Now, any interaction with these systems during diagnostics must ensure technician safety. This is extremely important because this is where a human life is at stake. All right. And next is vehicle safety and integrity. It must not cause any tangible damage to the vehicle. Component protection, regulatory compliance. Now, this is again very important in the business sense because if regulatory compliance is not met, then you cannot sell the vehicle in the market. So, key safety protocols in EV fault tracing. Now, use of personal protective equipment. So, we will talk about the equipment and also the purpose. First is class 0, class O or double O insulated gloves, protect against high voltage up to 1000 volts. Next is face shield or arc related goggles, prevent arc flash injuries. Okay, so this can prevent. There have been some rare cases where technicians got blinded because of high arc flash. And next is insulated tools, prevent current pass to ground, high voltage boots, eliminate ground conduction path, and flame resistant clothing protect from arc flash burns. Okay, so these are the various types of personal protective equipment. Now, considering the isolation procedures, high voltage disablement, also known as power down protocol, this ensures high voltage components are de-energized before touching or diagnosing them. Okay, so we'll see about this power down protocol. First, you shut off the ignition and wait for high voltage discharge time. Next is discharge high voltage battery, disables relays and ECU activation, and open HV interlock loop, acronymed HVA, a safety circuit that disables HV bus, and remove service disconnect plug, manual service disconnect, acronym MSD. Verify zero voltage before cat 3 using a cat 3 level high voltage voltmeter across high voltage bus terminals, and tag and lockout components. Now, talking about safe measurement techniques, when it comes to voltage, using this cat 3 or cat 4 meters rated for 1000 volts or above, and insulation resistance, use megameters with controlled voltage, continuity only after verifying 0 volts present. Now, talking about the current sensing, use non-contact clamps or Hall effect sensors. Okay, so talking about the safety zones and workplace controls, designate EV safety zones with barriers or cones. So EV safety zones must be clearly barricaded with the help of barriers and clothes, and put boards like high voltage work in progress signs, etc. Now, talking about ensure proper lighting and ventilation, limit access to trained personnel only. All right, because it's a very dangerous zone, only trained personnel should enter it, and it must be mandated. Battery safety protocols. When diagnostic faults in HV battery packs, in this table we are going to see the risk and the safety measures. When it comes to risk, thermal runaway, monitor temperature, never charge discharge damaged packs. Talking about the chemical exposure, avoid vehicle damage that could rupture cells. Short circuit, use pre-charge resistors, never bypass contactors manually. And when it comes to fire hazard, this is extremely important. Keep class D fire extinguisher nearby. Even though this is a very last resort, this is of extreme importance. Okay, of course, all the safety protocols are important, but this is kind of mandated and super important, because despite all these protocols, there is a good chance that fire hazard or fire catching fire may happen, and this is your last resort. Next is software and communication safety. During diagnostics using scan tools or flashing, follow OEM protocols only. Never interrupt firmware update process. All right. So if at all the update is happening, over the air is happening, you should never interrupt and use secure isolated laptops with proper ESD grounding. Avoid simultaneous charging and diagnostics. And when it comes to standard operating procedures for diagnostics, every workshop should implement diagnostic standard operating procedures. I'm sure everybody who has worked in a mechanical or automotive industry knows that if they visit the shop floor, lot of SOPs are stuck on the walls or on the boards. Okay, these are like the standard procedures that must be followed to ensure proper working of the automobile or the proper proper operating procedure. Now talking about the system disablement, LOTO, HVIL open, confirm, zero voltage. Talking about the diagnostics, fault tracing using tools, DTCs, scan logs, etc. And talking about the post repair validation, reconnect high voltage, clear DTCs, test drive. And documentation, record fault code history, fix applied technician, sign off. All right. So this is the these are all the standard operating procedures that must be implemented to have a safe diagnostic activity. Now, last but not the least, training and certification requirements. Only technicians certified for EV high voltage systems should perform diagnostics involving high voltage battery packs, inverter or onboard charging internals, isolation testing, live progging in powered conditions. Okay, this must be mandated, or this must be these are kind of rules that must be laid by the company. Now, common training standards like AASC L3, SAE J2990, IEC 60950, ISO 17409 or OEM specific EV HV certifications. Now, talking about the real world example, importance of safety in fault tracing. Now, talking about the scenario, technician skips high voltage disable procedure and probes the inverter directly with standard multimeter. Okay, so talking about the outcome, internal arc flash between the multimeter probes, HV fuse blown inverter damaged, technician suffers minor burns, and workshop shutdown and investigation initiated. Okay, so usually, usually these are the outcomes. These are the outcomes when you implement this importance of the safety in fault tracing. All right, these are the usual mistakes or errors that are observed. Now, let's see the summary table. So here we are going to see the safety category and also the key elements. So personal protective equipment like gloves, goggles, insulated tools, fire resistant wear, HV isolation, shutdown, HVIL open, the service disconnect, verify 0 volts. And safety tools, Cat 3, Cat 4 meters, insulated probes, IR testers, and work area, barriers, signage, ventilation, access control. And BMS battery handling, no forced charge, discharge, monitor temperatures, and avoid mechanical stress. And talking about the training, this is absolutely important. Certified electrical vehicle technicians only for high voltage work. All right. So hope all of you got a clear idea about the safety protocols. Thank you.